Good morning, everyone. My name is Chris. I manage outreach and public information for the Pacific International Space Center for Exploration Systems. We're an aerospace agency under the University of Hawaii at Hilo, and we manage aerospace development and research, and we organize programs like this. And this is the third Women in Space Exploration talk series that we're hosting. I just want to say a quick thanks to Hawaii Science and Technology Museum for generously supporting this program, and Microsoft, our friends over there, who encourage us to help get this program started. So with that being said, we're going to do a 30-minute presentation and 30-minute Q&A, and for all the young women who are participating today, you get first dibs on asking questions. So when you start putting your questions into the Q&A panel, just put the hashtag WiSE, W-I-S-E, so that we know to give you priority to get your questions answered. And so I'd like to introduce you to our host. Her name is Saeko Hayashi. She has worked with the Subaru telescope here in Hawaii, and she's going to introduce our speaker today. So I'll turn it over to you, Saeko.
Thanks, Chris. Aloha kakahiaka. Today, we are pleased to welcome Keri from NASA's Jet Propulsion Laboratory in sunny California. Keri is the deputy lead planner for the Mars Curiosity rover and an integration engineer for the Perseverance rover and Ingenuity helicopter, as you can see in her back. She grew up learning everything she could about the weather. In college, she earned a bachelor's and master's in meteorology at Texas A&M University, focusing on Martian weather. Keri has previously worked with the rovers on Mars, such as Opportunity and Spirit, the Mars Phoenix lander, the Hubble Space Telescope, and several asteroid missions. When she's not driving robots on other planets, she enjoys Star Wars themed activities and cosplay. Aloha, Keri. Please take us in.
Yeah, sure. Let me start sharing my screen here. Perfect. All right. So I'll talk a little bit about today about how I ended up becoming a Mars rover driver. And then once I kind of finish all of that up, I will be happy to take questions. So getting started, I was always interested in weather, even as a little kid. I would watch the Weather Channel. I grew up in the South, so Texas, South Carolina, Virginia. In Texas, of course, the very first week I moved to Texas as a 3-year-old, a tornado hit our house. And so it's a very vivid memory I have. And then when I lived in South Carolina, I had to evacuate from hurricanes. So weather's been a big impact on my life. So I was always interested in weather. And then my family was doing the Disney World vacation in Florida in July of 2005. And it just so happened to be the week of a space shuttle launch. I know it's a little hard to see, so I kind of have it in a circle there. But that was actually STS-114, which was the Discovery space shuttle launching. And so I saw that and said, gee, space is pretty cool. Maybe I'm interested in that. So then I went to space camp in Huntsville, Alabama for 2 years in a row. So this was kind of the end of my high school years here. And I got to meet a lot of really cool people and really get to know a lot more about space, and not only about like what astronauts are doing, but also things like exploring our solar system and growing plants in space and all that kind of stuff. And in fact, I even met some people there that I still work with at JPL now. So it's pretty cool that we got to meet so many years ago and work today in the space industry together. So then in May of 2007, I graduated from high school. And in May of 2008, I was working on the Phoenix Mars lander. The man in the picture there is Dr. Mark Lemon, who was my advisor. And he got me involved in space exploration right away. My very first week of college, I was listening into Mars rover planning meetings, and I had no idea what was going on. There's acronyms flying everywhere, but I thought it was really cool. So that's how I got addicted to working on space exploration and realizing you could study the weather on other planets. And that was the combination of space and weather that I loved. And so Phoenix landed exactly 1 year to the day from when I graduated high school, and my job on landing night was to be in mission control, putting the images up on the screen as they were coming down from Mars. So that was a pretty neat experience right out of high school to be in such a critical moment. It was pretty exciting. And I got to work on Spirit and Opportunity, taking pictures with their cameras, and then also with the Curiosity rover. I was there when it landed on Mars. And I also worked on the camera team, taking pictures of the sky. That was a part of the atmospheric science team as well. So we were using the cameras to look at pictures of dust devils and clouds and all that kind of stuff. And what does that tell us about the weather on Mars? So that was a lot of my college exploration. I joined the Opportunity team the very first week of college. So that was Martian day 1277 for the rover, and it lasted until 5111. And I was on it pretty much all of that time. So I got to spend almost a decade on the rover, which was pretty exciting. And then here's some pictures from when I worked on Phoenix. Every time that we make a Mars rover or any other spacecraft, we like to make what's called a test bed, where we try and make it as realistic as possible to the real spacecraft in space and try to make it match, because if we're doing something different that might hurt the mission, or something tricky, we want to test it here on the ground where it's easy to fix, rewrite the code, try again, rather than try and fix it in space. So that's another thing I've really enjoyed about JPL, is actually getting to work in the test bed and try, how do we drive differently if one of our wheels gets stuck, and that sort of thing. So it's one of the cool hands-on engineering aspects of my job that I get to do. And I had joined Curiosity actually about a year before it launched to Mars. So I was there for the launch and the landing, and worked on it until about a year after landing, all as a college student. And this was taking pictures of the sky, doing a bunch of Martian research. And the interesting thing about working on these missions right after they land on Mars is that you live on Mars time. So a Mars day is called a sol, and it's about 40 minutes longer than an Earth day. So imagine one day you're called into work starting at 8 a.m., the next day 8:40 a.m., the next day 9:20 a.m., and it goes all the way around the clock until you're starting at 3 a.m., you're getting off of work at 6 a.m. It's a very weird thing. Some people describe it as constantly being on jet lag, because you're jumping a time zone just about every day. I particularly like it. Maybe I'm a Martian at heart, who knows? But I found it to be really fun. You're working with like a whole bunch of really smart, intelligent people on a group. It's this huge group project trying to figure out, all right, we've landed this rover. Where are we? What is the cool science that's here? And trying to find that out. So I got to live that for the Phoenix Mars lander, for Curiosity, and then now for the Ingenuity helicopter as well. So once I graduated, I got to go to college, or once I got out of college, I got to start right at JPL. And the first mission I worked on was actually called the Dawn mission, which was on its way to the dwarf planet Ceres in our main asteroid belt. And I worked as a science planner. So what that means is I got to learn all about the science. I had a science background, even though there aren't really atmospheres on asteroids or dwarf planets. Just being around all the other scientists, I got to like understand a lot about how the different scientists do different work. And so I went ahead and was like the translator between the scientists and the engineers. So would talk to the scientists, say, hey, what kind of information do you need? And maybe it was certain pictures at this time of day, or they wanted to take some spectroscopy of this particular spot on the surface. And so then I'd work with the engineers who write the code to go operate the instruments and the spacecraft to point at the right spot and take the right observation at the right time. So I got to learn a lot more about the engineering side at that time. And I got to switch on Opportunity from being more of the science team into the engineering team. So I did a lot of different roles. The one that I did the most was called Tactical Uplink Lead. And that just means I'm in charge of like the day-to-day operations of the rover. So we come in, look at the data that came in from the previous night, say, okay, this is what we want to do. help the engineers write the code, solve the problems that may come up of whether we're using too much power, so we have to scale back on this, and do all that kind of trade and balancing to safely send something to the rover. So that's a lot of what I did for Opportunity. And I had just begun training to be a Mars rover driver for Opportunity when we lost contact. So unfortunately, I never got to drive Opportunity. But that has since been changed. I'll talk about that in a little bit. So one of the cool things, up until about 2 or 3 weeks ago, I was working on the Ingenuity helicopter. And so I would not be considered the pilot. I didn't write any of the commands to fly the helicopter around. But again, leaning back on that science planner style job where you're the interface, I was the interface between the Perseverance rover and the Ingenuity helicopter. So this is, when are we going to talk to the helicopter? Because the radio antenna is on the rover, so we need to coordinate around whatever the rover is doing. We have the videos like what you see here. So where's the helicopter going to be? Where is it flying? So when do we start the video? How do we point the video? Just all those kinds of things that require coordination between the teams. I was helping with that interface. And so now that I've left the Ingenuity team, I am working on Curiosity full time. And for quite a while now, about 3 or 4 years, I have been a rover planner on Curiosity. And that is the combination of Mars rover driver and robotic arm operator. We actually do both. And just about a year or two ago, I became the deputy lead rover planner. So I'm not only, driving around and using the robotic arm, but I'm helping train the next generation of Mars rover drivers, paperwork, any sort of management of the team that's needed, I help out with. And the new role that I'm just starting is I'm training to be a part of the systems engineering team for the rover. So you can see the role names there. But essentially, my job will become that I will be working on the day-to-day engineering operations of the rover. So making sure we can talk to the rover, making sure that we're doing any maintenance, any motors may need, anything like that. And just keeping an eye on the rover, making sure it is doing things safely. So that's a little bit about me. But what does it actually take to become a Mars rover driver? So you're probably thinking requires a PhD in robotics or computer science or some sort of background like that. Takes years of training, getting good at joysticks, and being super lucky. That's probably what you're thinking. In reality, you definitely do not need any sort of PhD in robotics or computer science. Now, it's not going to hurt if you have that. And certainly a lot of the early Mars rover drivers had that background. But it's really a lot more how you think, and then we train you on what you need to know. It does take years of training. Usually it takes 2 to 3 years to get all of your certifications for the rover planner role. We don't use joysticks. We actually write code that goes to the rover, and we don't communicate real time because Mars is so far away that you're actually, it's like 3 to 13 minutes for your signal to reach the rover and come back, depending on where Mars and Earth are in their orbits. So we actually have a lot of software on the rover that knows how to keep itself safe. So if it detects that it's drawing too much power on a motor, or it thinks that we're getting a wheelie or something like that, it'll actually stop itself. But we have to train the rover drivers on how to safely navigate, setting all of those safety limits, and just all that knowledge that we need, and what rock is safe to drive over versus not. And that way, we don't have to command in real time. We pick a path for the rover and then let the rover decide if it's safe in the end. And I do have to say it is a little bit of luck, just kind of being at the right place at the right time to get into one of the classes for being a rover driver. So a little bit more about the degree part. One of the guys who basically invented how to drive Mars rovers back in the day has a bachelor's in fine arts in sculpture. He did eventually go on to get a computer science degree, but that was his first degree, was in sculpture. Another one did a computer science major combined with English and spent a lot of time writing about the experience. And as I said before, I have a bachelor's and master's degree in meteorology, which is looking at the sky. It has nothing to do with robotics, has nothing to do with rocks. And so it's a lot more about like how you think than what you know. We'll teach you what to know. And speaking of teaching, you do have classes and homework if you want to become a Mars rover driver. You have to learn all sorts of things. So you have to analyze telemetry. That's all the data coming back from the rover. And so we have to make sure, okay, we told it to do this. Did the rover actually do that, or did it encounter some issue, or did it slide a little bit? You know, what happened? We have different ways of driving. We can be very specific of go forward 1 meter, turn 30 degrees, go forward 1 meter. Like we can be very specific. Or we can say, okay, there's a rock 50 meters in the distance, you figure out how to get there. So we have to learn what type of driving is best for what scenarios. We also have safety checks. So I mentioned a few of, you know, are we drawing too much power, or did our suspension system encounter something weird? Like, it's a lot of different ways that we can keep the rover safe. And we have the ability to make the rover more aggressive in terms of driving, or be very conservative. And so you have to learn how to, you know, what's the right situation that keeps the rover safe. What is safe to drive over? So the picture here is actually the very first homework that we give you. We give you this picture and we say, okay, you have to measure the 20 biggest rocks in the picture and tell us which ones would you feel comfortable driving the rover over and which ones would you not. And so just because there's so much to learn, it usually takes at least 1 to 2 years. So, you know, we'll teach you a little bit about the actual hardware. We'll teach you about the software that we use to write the code. We'll teach you about all the different drive modes. We'll teach you how to interact with the other people that you're planning the rover with. And this is all just for driving. Then there's a whole nother series of classes to operate the robotic arm. Speaking of which, we also wave the arm around. So some of the things we do is actually drill samples on Mars. Curiosity, the original name for it was Mars Science Laboratory. It actually has several labs shrunk down into the body of the rover. So we collect rock samples and then put those samples into our onboard laboratories to do analysis and figure out like what the rocks are made of. We also have a brush, so you can see where the rover brushed a little bit and the rock is a little more gray underneath. It's actually all the dust on the surface is red, and we've found as soon as you brush it away, all the rocks are gray. So Mars is actually pretty gray. It just looks red because of the dust. Of course, we also like using it as the perfect selfie stick. So every time that we drill a sample on Mars, we do a documentation selfie of the site. And so that little animated GIF was also a picture of the rover looking at the robotic arm as it was taking the selfie. Because that's the #1 thing we get asked, how do you do it? So it actually takes a whole series of images to be able to cover the whole field of view around the rover. So personally, I have driven 946 meters on Mars and helped fly 1.3 kilometers. It's a lot slower to drive a rover than it is to fly a helicopter. So it's pretty neat that in 1 year of helicopter operations, we've flown so far. And I've been on Curiosity since 2018 and haven't reached the total in 1 year that the helicopter did. So I'm really excited to see where the helicopter continues to fly, continues to help exploration as well. And I also posted here some of the official NASA accounts on Twitter and Instagram and that sort of thing. I can usually be found as Planetary Carry, and there's also our website. And I want to talk a little bit about this one last picture. So one of the things we actually get to do sometimes is actually use the rover as a science instrument. So we typically don't like driving the rover in sand just because sand is very slippery. If you've ever like walked on a sand dune or on a beach, you know how it's kind of hard to like walk sometimes. The rover does the exact same thing. So what we did here is we parked next to a big sand ripple and actually drove the rover up into it and spun a wheel in place to dig a little trench into the ground. And then we backed up and then repositioned the rover such that we could actually get the robotic arm out in the next plan and look at the sand that was just beneath the surface. So that's some of the cool things we get to do as a rover planner. And I like it because I get to leave cool tracks on Mars. And so with that, I think I will open it up for questions.
Thank you, Keri. It was just mind-boggling. Okay, so let's see. The question comes in from Avi. How many programming languages do you know?
Oh, that is a good question. How many programming languages do I know? And the answer is none. I know that probably sounds weird. I actually don't know how to code. I don't know Python or anything like that. Uh, Technically, we do like have a coding language to program the rovers, but it's not really a programming language that you would think of, you know, the most fancy we can get is if else statements. It's very simple, very simplistic. And a lot of the code is actually automatically generated for us. So I don't have to like memorize and write it by hand. So I know that sounds really weird. And I'm like one of the very few people that does not know how to code. You know, certainly you have a much better chance of getting a job if you know Python or something like that. But I'm one of the weirdos.
Well, but you're doing a great job. So here's another question followed by the first question, which is, and were you into computer science in high school or college, or do you wish you had explored it more to prepare you for your job now?
Yeah, so a little bit. So I did take the advanced placement computer science classes in high school. So that was in Java. I don't know if it's still Java now. And so I knew a little bit. And then in college, I did learn a language called IDL, or Interactive Data Language, which is really well known for processing images since I was working on the camera teams. But I didn't write a lot of the code. Usually I was using like programs that other people had written. I did have to write a little bit for my master's thesis on processing the specific set of images I was looking at, but most of the time I didn't have to code things myself. I'm probably one of like the last generation of people that could get away with not really knowing how to code. I think now it's a lot more, you know, common for people to learn how to code. There's also a lot more programs now as well on learning how to code that didn't exist when I was going through school. So, you know, if you don't get it, don't worry. That doesn't mean you're disqualified from working from NASA or anything like that. But I think it's certainly something that if I was going through school now, I would spend a lot more effort trying to learn.
Yeah, it's more like open-minded and learn as you go kind of thing.
Yeah, I get away with it by being really good at writing, and engineers hate to write documentation and procedures and all that. So I do all of that for them. I'm like, you write the code, I'll document it. So that's how I get away with it.
Okay, let me go back to the question. What advice do you have for middle and high school students who are interested in space science but don't know where to start?
Yeah, so I think trying to just read and learn about all the different aspects that you can. So one of the missions I worked on in college was actually on the Hubble Space Telescope. I worked with a professor in our astronomy department, and I found that actually doing the astronomy stuff, I just was completely not interested in, which is really funny because like I have a telescope, I love to go look out at the night sky, but whatever it was, I just was not interested. So I worked on Hubble until my project was done, and then I moved on. I was like, okay, not doing the astrophysics route. And you know, if you're interested in robotics, I know First Robotics is a really great program. There's a couple of other like robotics programs focused on students. If you can find a way to get involved in those, that's another good way to find out what you're interested in, if robotics is for you. You know, as you get older, maybe starting as you're starting to think about like going to college, like email professors, because usually they'll be happy to talk with you, because most of the time we're working on stuff that we love. And if someone is interested in hearing about that, we want to tell them all about it, just like I'm doing right now, talking about this. So if you have an interest in anything, just see if you can, you know, schedule a Zoom meeting for an hour sometime. You know, get out there and just try to find out, try new things.
Yeah, well, for the students in Hawaii in particular, WiSE is the starting point. They can offer the connections or actual programs. And also there are many robotics programs in the schools in Hawaii. And if you are not if your school, the student school is not participating, then there's a group in with Science and Technology Museum in Hilo that students from any school can get involved. A little bit of advertising.
Yeah.
Okay, and then next question from Courtney. You mentioned that it is more about how you think. What is the type of mindset needed for this type of work?
Yeah, great question. So the mindset that you need, a lot of it is multitasking. So early on in the day, the scientists are going to come up and they're like, okay, we're interested in looking at this rock and this rock and this rock, but also we want to drive over here. And so you have to think like, okay, what's the highest priority? How do I analyze, like, is it safe to touch the robotic arm with this rock? Or how do I touch this target with the robotic arm? Or then you start thinking like, okay, what kind of rocks are dangerous on the drive? And so how am I going to maneuver the rover around the rocks? And you also have to be very good at collaboration and teamwork. So that means a lot of communication as well of whenever we like drive a rover, it's never solely by yourself. We always work in a team of at least 2, usually 3, sometimes even 4, depending on, how complex the activities are that we're doing. And so, we can, if I'm in charge of the robotic arm for the day, I'm going to say, okay, one of the other rover planners, can you please take a look? I'll look at this rock and you look at this rock and see which one comes out better for doing the science today. Or maybe we can do both, or, prioritize and be able to communicate is probably some of the biggest, things you have to have in your mindset. I also like seeing people that can push themselves and, accept that, sometimes you're going to make mistakes, sometimes you're going to fail. But how do you learn from that? How do you keep going? I think that's another big aspect. I'm happy to admit when I make mistakes, and I'll say, okay, I messed up. Here's the error that was made. How are we going to make sure that this is not going to happen for someone else? Like, do we need to retrain everyone on a specific procedure? Or maybe this was just not thought of before. And so, we need to write documentation about why this is a bad idea or something like that. I'd much rather work with people that are, forthcoming instead of like trying to push blame on someone else or, hide the problem or something like that. Like, I'd rather you admit failures and, let's move past it rather than, try to hide or be embarrassed about it.
Yeah, because you're doing something that not many people have done. So, and you try to do new things.
Yeah, here's where I get to do the pat on the back moment of there's fewer Mars rover drivers than there are astronauts. So, see, right? So, there's not many of us. And so, we want to make sure that we're trying to keep the rover safe as well. We are one of the very few roles that can actually physically break something on the rover if we did something wrong. Yeah. So, that's a lot of responsibility for a multi-billion-dollar robot. So, I'd much rather work with an open, communication team than a closed communication in that kind of stressed environment.
Yeah, that's very important. So Aoi wants to know 2 things. What was the most challenging part of your career so far? And the second one is the most rewarding part.
Gosh, I think I actually have a combined answer for both. So it was kind of the end of the mission for the Opportunity rover. So, the Opportunity rover was only designed and was supposed to only last 90 days, 3 months. And it lasted a lot longer than that. It landed in early 2004 and lasted until 2018, like mid 2018. And as you go along, parts start to break. We lost the ability to steer some of our wheels. Our robotic arm, we could no longer use our shoulder joint to do this kind of motion. We only had a line to be able to target with our rocks. We couldn't, move around the arm. So that was difficult. And so just being a part of a really small team, because the further you get away from what we call your prime mission, the less money NASA gives you. So the team gets smaller, you're able to do less things. But just being a part of that small, close-knit team, especially when we lost contact. So essentially, Opportunity was a solar-powered rover. And when there was a major dust storm on Mars that completely blocked out the sun for months. And as you can imagine, if you can't see the sun, it's not really good for a solar powered rover. So unfortunately, we lost contact. And then we had to think through what can we do to try and get the rover back? No one has ever attempted something like this with one of our Mars rovers. So we had to think through, okay, well, if it's been long enough and the power got low enough, maybe its internal clock stopped working. So how do we send the clock reset? How do we, we just had to think of all the things that could have gone wrong and try to come up with ways. So we would literally come up with a plan, test it on our testbed rover here on Earth, and then send it to Mars and wait. And we didn't hear back. We're like, okay, well, let's either try that again or come up with a different method. And we did that for weeks and weeks and weeks, trying to get the rover back. And so, it was very stressful. And even though we didn't get the rover back, it was extremely rewarding to be working that closely with such a great team. We were a really close-knit family, essentially. So that was one of the saddest, but also one of the best experiences I've had at JPL.
Mm-hmm. So stick to what you love to do.
Mm-hmm.
Don't give up.
Mm-hmm.
Okay, so let's see. Any other question from, let's see. Chris, is there any on Facebook?
Yes, check your chat window. I put one in there for you.
Oh, yeah. Okay. Oh, yes, indeed. This is very important. You said one Mars day is different from one Earth day. What about the communication gap? Have you been living on Mars time plus compensation for that time lag?
Yeah, so typically for about the first 3 months when a mission lands on Mars, we live on that Mars time. But as you can imagine, that starts getting really hard, especially if you have family or kids or anything like that that live on a regular Earth schedule. So we only do it for the first couple months when we're trying to do what's called the commissioning phase, where we're checking out the instruments, making sure everything works, doing our first drives, like just trying to figure out the rover now that it's on Mars. And then we switch into planning just during normal Earth hours. Usually starting out, we are planning every single day a week, but we're not planning at like 3 in the morning. Maybe we'll start as early as 5 a.m. or end as late as midnight. And then as the team gets better over time and we're more familiar, we'll drop days, shrink that window. So like for Curiosity, who's been driving on Mars since 2012, we typically only plan on Monday, Wednesday, and Friday, occasionally Tuesdays, but usually Monday, Wednesday, Friday. And so what we do is we actually send 2 to 3 days worth of planned activities at a time. So maybe on the first day, we'll plan the robotic arm activities, and the second day, we'll plan a drive. And then the third, we'll do what's called untargeted science. So since we don't know where the location of the drive is, this may be like looking at the sky, because the sky is always going to be there. Or doing a full panorama around the rover just to see what's around us. Then all of that data gets sent back. And we're okay with the untargeted science happening while we plan the next set. So we call that restricted planning, where we don't have everything that the rover has done in that time frame back. But where the Earth day aligns with Mars night, that's what we call nominal planning. So that is where we get the data. When the rover is going to sleep, it sends back the data at the end of the day. And we spend that Mars night planning the new activities. And then we have enough time to send it up in the morning. So that's when we'll plan on the Tuesdays, just to take advantage of the fact that we're in more constant communication with the rovers.
I see. So planning is the key, really the key. Okay. Here's another interesting question. Well, your background was weather science. And when you switched to this more of the engineering aspect of this science project, how was it like?
Yeah, so that's a great question. So I was really uncertain at the end of my master's program of whether I wanted to continue in a PhD and continue to do science, or if I wanted to go to JPL and start getting involved more in the day-to-day engineering operations of the rovers. And my advisor very correctly said, you know, I have no issues with you getting a PhD. You're smart enough, you're dedicated enough, you can do it. But I think you'll be much happier if you go to JPL, because a lot of what I was experiencing was being in a cube by myself working on my project. I wasn't doing that collaborative environment. So when I was working on Mars time with all those different scientists or helping to operate the rovers, you're still very technical work, but you're working with a team. And so I really needed that social team aspect. And so my advisor told me, no, go to JPL, you'll be much happier. And he was certainly correct. And so, you know, I've certainly done less science over time. But the background with like collaborating with the science team members, they're like, oh yeah, Keri knows what this means when we want to like take a picture of the Martian moon in eclipse. Like, and I try to teach that to the other engineers of trying to cross that science engineering world of making the engineers appreciate, okay, no, the scientists really do mean this is an important observation. This is the only day we can do it, versus like, you know, teaching the scientists, no, this really is an important engineering thing that we need to do. We need to delay the science to the next day. So even though I'm still an engineer, I still try to keep that hat on. And that's actually one of the things that I was interested in working in Ingenuity about, because we actually do have to do Martian weather forecasting for our flights. So I wasn't involved directly in the weather forecasting, but that was, you know, it involved a lot of that like rover planner, rover driving background. We were using a lot of the same software, but now I also got to include that Martian meteorology background that I have. So that was one of my favorite things about working on Ingenuity, is I finally got to like, you know, get those two halves of my brain together for once.
Yeah.
It's been an interesting change. You know, sure, I'm not doing all the science all the time, but I'm still working with a lot of the same people and helping them continue to do their science. So I still find it pretty exciting, and it's a challenge for me. That's part of the reason I actually just changed to the engineering, systems engineering side for the rover. You know, I don't have an engineering degree. I didn't take thermodynamics. I took atmospheric thermodynamics, but not engineering thermodynamics, that sort of thing. So I expect to be learning a lot. They have a lot of classes and everything as well, just like the rover drivers. So very excited to challenge myself, and, you know, I'm sure I'll stumble and fail, and I'll learn and keep going.
Again, open-minded. You just keep learning. That's just incredible. Okay, so here is a very interesting question, and I want to ask this one as well. When do you think people will go to Mars?
Gosh, when will people go to Mars? I wish I knew. You know, I think our technology is getting better all the time. We're starting to solve a lot of the problems we would have had with the International Space Station of, you know, how do people live in space for that long amount of time? So I think our technology is slowly getting there. I don't know if it'll be in my lifetime or not. It sure would be cool if it was. But yeah, we'll see.
Yeah.
Maybe it'll be one of you.
Yes, indeed. Yeah, that's what I was about to say. Please. Okay, and then here is another career question. Did you have management classes or information or formation to learn how to work in a team?
Yeah, so I actually have taken a couple leadership classes at JPL, and you know, they've helped a lot. One of the classes I really appreciated, and I think you can even get it online, and it's a book. It's called Crucial Conversations. And so this one is really about how to have those conversations that are difficult, whether as a team lead, I'm having to give feedback to a person of like, you really need to work on this skill, or I need to approach somebody and be like, hey, this is incorrect. I need to bring it to your attention. We need to do something about it. So that class was extremely helpful in like, you know, learning how to navigate those kinds of conversations. And you know, JPL offers a wide variety of those classes. I'm sure a lot of other like aerospace industries companies do the same. That's one of the things I like about JPL is they're investing in their people. Like, they want to teach you, they want to train you, they want to like help guide you in whatever you're interested in. Yeah, I think that's all I have to say about that.
That's great. There is a question about what you learn in college. Okay, so let me read this. What is one essential thing that you would recommend to do or to learn for an undergrad looking to get involved in space technology / robotics? What is the biggest difference between space science and space engineering?
Yeah.
Actually, 2 questions.
Yeah. So I think for the first part of the question, I would say try to get either working with a professor at college or doing internships. Again, just trying to find different things, whether it's the more sciencey side or the engineering side. A lot of companies, JPL offers internships every summer. Lots of companies offer internships. It's a really easy way to get like a short dose of what it's going to be like working in that industry. I've had an intern the last several summers and they've all worked on different things. So the previous intern I had just this past summer was actually in library science. So our information for rover planners are all stored in a wiki page, internal, wiki style documentation. And it was a complete mess. It was hodgepodge, people wrote little snippets everywhere. And so we actually had a library science student go through and organize all that information for us. And the previous summer, I had been working on the Perseverance mission as the training lead. So I was in charge of training everyone on how to operate the rover. And so the student I had was helping me develop those first initial classes. So Mars 101. So whether you were a scientist or an engineer, you got to learn a little bit about all the science that the mission was going to be doing and what we know about Mars today, a little bit about the engineering of the rover. Here's the different instruments, here's what they do, here's what the mobility system is like, here's the robotic arm and everything you need to know about it. Just trying to get everyone on the same page. So that was my previous intern. So, even though they're not like specifically like, oh, I'm helping to build this piece, there are still lots of internships like that at JPL as well, where you get to actually build hardware, work in those test beds, that sort of thing. But I've been trying to focus a little more on the non-traditional side. I forgot the second part of that question is the difference between space science and space engineering.
Yes.
That's right, yes. So the science is more looking at the data that's coming back to, like, for example, with the rovers, they can do the chemical analysis in their laboratories and that information coming back and saying, oh, well, that means this mineral is here. And because this mineral is present, that means this used to be in a lake bed back, 3 billion years ago or whatever it was. So, that's a lot of the science is actually trying to figure out like geologic history or, what kind of atmospheric processes are taking on right now. Whereas the engineering is more about building the spacecraft and designing the spacecraft that will accomplish those science goals. So, when a mission is picked, even before that, scientists and engineers will actually get together and the scientists will say, I really want to go to Europa and study, the ocean underneath Europa. And so then they'll work with the engineers like, okay, well, Europa is in the radiation belt of Jupiter. So we need to design a spacecraft that will be able to survive in the radiation environment of Jupiter, which is really high radiation. And so then they work together like, okay, well, if you want to do this kind of science, then we need to develop the instrument this way to safely operate in that kind of environment. And that's true for the Mars rovers too. Like, we want to be able to detect this kind of mineral. So we build the instrument, what kind of attachment does it need to the rover that we're going to send? It's kind of a collaborative part between the scientists and engineers. So just because you pick one or the other doesn't mean you can't kind of blend both, just as I have.
And the team needs both.
Mm-hmm.
And exploration needs both.
Yeah.
Now I have a question. What is engineering uplink and tactical downlink?
Yeah, so the engineering uplink lead is kind of the person in charge of the day-to-day engineering activities of the rover. So if there's maintenance that needs to be done on a particular motor or a diagnostic activity, if something went wrong in the previous plan, they're the person responsible for that. The tactical downlink lead is the person in charge of all the information that came back from the rover that day, of analyzing it all. So there is a team that'll look. So there's like a power person that's looking at how much power was used, and a thermal subsystem of like, did the rover get too cold? Did it get too hot? They're looking at all of that. And so the TDL, or tactical downlink lead, is kind of the person that pulls all of them and checks the overall health and reports it to the day-to-day operations team of like, okay, the rover's healthy, or we had an issue with this instrument, so let's not use the instrument today, but you're okay to do anything else with the rover, all that kind of stuff. So it's a lot more of like that engineering side than, working with the scientists to get things done.
Wow, the operation involves a lot.
It's a big team. We're usually planning with 30 to 40 people at a time. So,
Wow.
you're never alone in this world, which is one of the things I like about it.
I see. I see Chris is going to say something.
Well, that looks like all our questions. That your job sounds really awesome, Keri. Thank you for being here today, sharing your experience and your expertise, and giving our participants a little idea of what your work is like and how they can get involved and pursue what they're passionate about. Yeah, and thank you, Sayeko, for being here, sharing your time to serve as host. Really appreciate that. We will have a recording of this talk available on the WiSE Talks webpage, so you can go back and review it or share with your friends if you like. It's at the pacificspacecenter.com. Just pacificspacecenter.com. Hope we see you tomorrow. We're going to have another talk with Dr. Kelly Leppo. She's an outreach scientist at the Space Telescope Science Institute, and she's going to talk about the James Webb Space Telescope, which should be really interesting. This is a next generation space telescope, which is anticipated to really change our understanding of the universe. So yeah, thanks everyone for joining us. And once again, mahalo to Hawaii Science and Technology Museum for supporting this event. And we'll hope to see you all tomorrow. Hui ho.
Bye. Thank you.